Hello students, welcome to the second episode on understanding quadrilaterals. In the first episode, we have learnt that a four-sided polygon is called a quadrilateral. Today, we will see different kinds of quadrilaterals based on the nature of sides and angles in a quadrilateral. First, let us begin with this quadrilateral. Let us observe two sets of quadrilaterals which are appearing on the screen. Here is the set 1. Here the arrow marks indicate that the two sides are parallel. Now here you see the set 2. What is your observation about the quadrilaterals in the set 1? All quadrilaterals in the set 1 have a pair of opposite sides parallel and another pair of opposite sides not parallel. But in the set 2, this property does not hold good. A quadrilateral in which exactly one pair of opposite sides is parallel is called a trapezium. So, the quadrilaterals in set 1 are all examples for trapezium, while the quadrilaterals in set 2 are not trapeziums. So, this is the first kind of quadrilateral. Now, let us move to the next kind of quadrilateral. For this, let us do an activity. Now, I am taking a piece of cardboard sheet, fold it like this. Now choose two unequal line segments from the two endpoints. Maybe I will choose this point. Join this point to the two endpoints of the folded edge. Now cut along these line segments. Now on opening this, what do you observe? This is a quadrilateral, right? How does this look like? Doesn't it look like a kite? Yes, such quadrilateral is called a kite. Now to see how to define this, let us see what are the nature of sides and angles in a kite. Let us call this quadrilateral as A, B, C, D. Now this side BC and side CD are obtained by cutting this line segment. So you see that the length of BC is equal to length of CD, and similarly length of AB is equal to length of AD, because they are obtained by cutting this line segment. So this gives us the idea how to define a kite. A quadrilateral with exactly two pairs of equal consecutive sides is called a kite. Let us see some examples of kite. The quadrilaterals in this figure are all kites. The quadrilaterals here are not kites. Now with the kite that we have cut, let us observe some properties of kites. Exactly one pair of opposite angles coincide. One pair coincides, whereas the other pair of opposite angles are not coinciding. This means exactly one pair of opposite angles is equal. Observing the diagonals, we see that the longer diagonal bisects the smaller diagonal. Therefore, we have the following properties of a kite. Property number 1, the diagonals are perpendicular to one another. Property number 2, one of the diagonals bisects the other. Property number 3, exactly one pair of opposite angles is equal. We now move to the next kind of quadrilateral called parallelogram. The name parallelogram itself suggests that this kind of quadrilateral has got something to do with parallel lines. Observe this: when two pairs of parallel lines intersect as shown on the screen, they form a quadrilateral which looks like this. Such a quadrilateral is called a parallelogram. Precisely, a parallelogram is a quadrilateral whose opposite sides are parallel. Since the perpendicular distance between parallel lines remain the same throughout, we have the following property of parallelogram. Property number 1: the opposite sides of a parallelogram are of equal length. Now, let us consider a parallelogram PQRS. Then, by joining the diagonal PR, we have two triangles PQR and PSR. Since opposite sides are equal and the side PR is common for both these triangles, we see that triangle PQR is congruent to the triangle PSR. Therefore, angle Q is equal to angle S. Similarly, by joining the diagonal SQ, we can show that angle P is equal to angle R. Therefore, we have the following property of parallelogram. Here is the property number 2. The opposite angles of a parallelogram are of equal measure. Now, let O be the point of intersection of the diagonals PR and QS of the parallelogram PQRS. Now, let us mark angles 1, 2, 3 and 4 in this. Since the side PQ is parallel to side SR, we see that angle 1 is equal to angle 2 because they are alternating angles, and angle 3 is equal to angle 4, again they are alternating angles, and therefore, by ASA congruence criterion, the triangle SOR is congruent to the triangle POQ. Thus, the corresponding sides of congruent triangle are equal. So, we have the side OS is equal to OQ, OP is equal to OR. So, what do we observe? The following property is observed. We have property number 3, that is, the diagonals of a parallelogram bisect each other. Now, let us see some special parallelogram. To see this first special kind of parallelogram, again let us do an activity. Again, I am taking a piece of cardboard sheet. Next, fold it like this. Again, fold this to mark the line that divides the area into two halves. Are you able to see that mark of that line? Now, choose any point on this line. Let me choose this particular point. Now, join this point to the two end points of the folded edge through line segments. Okay. Now, cut through these line segments. Then, we have the following figure. We observe that all the sides of this figure are equal. Therefore, opposite sides are parallel, and thus this kite is a parallelogram as well. We call such a quadrilateral as a rhombus. So, we have the following definition. A rhombus is a quadrilateral whose all sides are equal. So, every rhombus is a parallelogram as well. Now, we move to the next kind of parallelogram, namely rectangle. Suppose PQRS is a parallelogram whose all angles are equal. Then by angle sum property in quadrilaterals, the sum of all angles is 360 degree. Thus, each angle in PQRS is equal to 90 degree, which is 360 degree by 4. A parallelogram whose all angles are equal is called a rectangle. What we observed is that a rectangle can also be defined as a parallelogram whose one of the angle is equal to 90 degree. Let us see an example of a rectangle. Looking at the figure, we clearly see that triangle ADC is congruent to the triangle BCD by SAS congruence criterion. Thus, diagonals AC and diagonal BD of equal length. Therefore, we have the following property of a rectangle. Here is the property: the diagonals of a rectangle are of equal length. We now move to next special kind of parallelogram called square. Let us consider a rectangle BELT whose all sides are equal. Then on joining the diagonals BL and TE, we have the following figure. Since BELT is a rectangle, the diagonals bisect each other, and thus all the 4 angles at O are equal. But we know that the angle around a point is 360 degree. Therefore, each of the angles at O is 90 degree. Such a parallelogram is a square. We have the following definition: a square is a rectangle whose all sides are equal. And by the above observation, we have the following property of square: the diagonals of a square are perpendicular bisectors of each other. We have now seen 3 special kinds of parallelogram. This ends our discussion on different kinds of quadrilaterals. Let us now recollect what all we have learnt today. We first defined trapezium, then kite, and then we defined parallelogram. We then learnt some properties of parallelogram. Then we learnt some special cases of parallelogram, namely rhombus, rectangle, and square. We also learnt their important properties. With this, we end up our episode on understanding quadrilaterals. Thank you. Have a nice day.